All right, here is your homework for targets 9 and 10, the last target homework assignment you guys have. So taking a look at this, just bear with me. I'm going to have to make 3 tables on each of these problems since we're graphing logarithms. And so I just might run out of the room, might get a little messy. I'll do the best I can. So on number 1, we're graphing log base 4. So first of all, before I get into this, if you haven't watched the video on the notes, super important that you do that first. We're in log base 4, which means if you remember, we are going to start with y equals 4 to the x and make a table for that. So the exponential function in the same base. So this is exponential growth. So I'm going to start with 0, 1, 2. I went positive because it was growth. So 4 to the 0 is 1, 4 to the first is 4, 4 squared is 16. That's going to go off our graph, but we'll keep it around just for fun. Okay, so then I'm going to go to y equals log base 4 of x, and the only thing I'm going to do to make this table is I'm going to switch the x's and y's. So the y's that I just wrote became the x's became the y's. The reason we do that is because these are inverse functions, and that means we switch the x and y values. You guys did that in a previous target. The last table I'm going to make is over here on the right-hand side. The transformations. This is the horizontal, it goes opposite, so I'm going to do x minus 1. And then this is going to be the y, and it does exactly what it says, so y minus 3. So this is a progression. That's the first table. This is the second table. This is the third and final table, and this is a progression. So I'm going to go back to table 2 and subtract 1 from each of those. So make sure you don't go back to table 1. That would be anti-progressive. All right, so y minus 3, so that would be negative 3, negative 2, negative 1. That points off the graph, we can digit. 0, negative 3, and then 3, negative 2. And then we have a vertical asymptote on these. So it's following whatever the horizontal transformation is. So remember that was a negative 1 because we did the opposite, and that's going to be the vertical asymptote. And then we're going to curve, hit those points, and then curve down. So it looks like an exponential function that has been toppled over. All right, on number 2, so this is where things are going to get a little scrunched, I think. I'll do my best. This is log base 5, so I'm going to start with y equals 5 to the x. So going back to when we graphed exponentials, I'm actually just going to do 0 and 1. 5 to the 0 is 1, 5 to the first is 5. If I did 5 squared, it would be 25, and that's off the graph. Then my second table is getting this to a logarithm, which means I just switch the x and y values. So this is a 1 and a 5, this is a 0 and a 1. And then my last table, I'm going to make that over here to the left, is your transformation. So x minus 4 and y plus 3. And again, make sure you do this based on the second table. So subtracting 4 from the x values, that would be a negative 3 and a 1. And adding 3, that would be 3 and 4. So I'm going to plot these points, negative 1, 3, and 1, 4. Last thing is your vertical asymptote. That'll be at negative 4 for this one. So the math behind this really isn't tricky. It's making that first table is really the only math, and you guys have hopefully mastered that when we graphed exponential functions. It's just that logarithms are brand new, and that can just feel a little uncomfortable in and of itself. All right, continuing down, let's do number 3. So this is log base 3. So you'll notice the pattern is the same every time. I'm going to start with y equals 3 to the x. I'm going to use 0, 1, and 2. So 3 to the 0 is 1, 3 to the first is 3, 3 squared is 9. The second table, all I'm I'm going to do is switch the x's and y's, and that just gets us into logarithms, which is what we're graphing today. 0, 1, 2. And then our last table is going to be x minus 1 because it's the opposite of inside parentheses, and y plus 2. So if I subtract 1 from each of the x's, that would be 0, 2, 8, and add 2 to each of the y's. That would be 2, 3, 4. I'm going to graph those points. Oh, hold on. I graphed that wrong. All right, 0, 2, 2, 3, 8, 4. And then the vertical asymptote would be at the opposite of the parentheses at -1. I'm just realizing now as I say that these might ask for domain range. Yeah, we didn't do the domain range and vertical asymptote. That was my fault. So I'm going to go back. I'm going to pause where I was on number 3, and I'm going to talk about the domain of number 1. So the domain is everything to the right of the vertical asymptote. So x is greater than -1. So it's kind of strange because we're used to our domain being all real numbers, but that vertical asymptote keeps it from going to the left. The range, this graph does go forever up and down, so that one's all real numbers. And then the vertical asymptote, if you look at this graph, we graphed it at -1. A vertical line is always x equals, so we say x equals -1. Doing that for number 2, the domain is x is greater than -4. So notice it's always x is greater than, and then we're just finding where that vertical asymptote is. This graph is going to go forever up and down, so the range is all real numbers. And the vertical asymptote, like I mentioned, is at -4. And then catching back up with where we were, the domain on this one is going to be x is greater than -1. That's the vertical asymptote. The range is all real numbers. And again, the vertical asymptote is at -1. Sorry about that. All right, moving on to number 4, we get a little nervous because we see a fraction, but we can handle it. So the base is 1/2. So we're going to do y equals 1/2 of x. So if you remember back to earlier in the unit, this is actually decay. So instead of using positive numbers, I'm going to use negative numbers. So 1/2 to the 0 is 1. 1/2 to the -1 is 2. It just takes the reciprocal. Exponent of -2 would result in 4. -3 would result in 8. So then to get to log base 1/2 of x, we're just going to flip those x and y values. 1, 2, 4, 8, and 0, -1, -2, -3. All right, and then our last table, I'm going to make that over here to the left-hand side. We're going to do our transformation, so that would be x plus 1 on this problem, opposite of that, and y plus 2. So make sure you use the right table. I'm going back to this table over here, so adding 1 to each of the x values. 2, 3, 5, 9, which I don't think fits on the graph. And adding 2 to each of the y, so that would be 2, 1, 0, -1. So we have the point 2, 2, 3, 1, 5, 0, and then 9, -1, which would be right about there. The vertical asymptote would be at +1. And if you notice, the shape looks kind of different on this one, because it curves downwards. And that's just because of the 1/2. That's how that changed things. So that's why it looks a little different. So the domain is x is greater than 1, so everything to the right of the asymptote. The range is still all real numbers, even though it has a little bit of a different shape. and the vertical asymptote is at x equals 1. All right, we've got tables everywhere. Hopefully the color coding is helping. All right, we have y equals log base 3. So what I want to point out is if you look up here at number 3, we actually did a log base 3 problem already. So we could use that table and just apply these new transformations. So we're doing x plus 1 and y plus 4. So we actually don't have to do all 3 tables here. You absolutely could. But if you notice on a previous problem, you're like, oh, I've already done a log base 3. Like, look up here, this is a log base 3. Then go to that second table and just use your new transformations. So 2, 4, 10. I added 1 to each of those x values and 4 to each of the y. So that would be 4, 5, 6. I love something that lets me be a little bit lazy. And then this asymptote would be at positive 1 since it says x minus 1. And then we have our curve. That was a pretty good curve. I do say so myself. So the domain here would be x is greater than 1. The range would be all real numbers. And the vertical asymptote is at x equals 1. All right, last problem. I don't think we've had a log base 4. Oh, we did have a log base 4. That's way up here though. So I'm going to actually redo all of the tables just so I have them down there. I don't have to keep scrolling, but what you could do is just use this table and apply your new transformations. But like I said, it kind of makes me motion sick when I keep scrolling. So I'm going to go ahead and recreate those tables. So this is base 4, so y equals 4 to the x, y, 0, 1, 2. So 4 to the 0 is 1, 4 to the first, 4 squared. And then we're going to switch them. And you'll notice that these are the exact same tables that we used in number 1. So that's why I was saying you can just bring those down. If you're looking at a piece of paper, you can see them all at once. I just can't do that on here. So I'm making the x's the y's and the y's the x's. And then if you were taking a shortcut, I'll meet you here. So it would be x minus 6 and y minus 3. So I'm going to use this table, but again, it is the same exact table as this one right here. So if you use that, that's great. All right, subtracting 6 from each of these x's. So that would be negative 5. That would be negative 2. And that would be negative 10. No, positive 10. What am I doing? Okay, and then subtracting 3 from the y's. Negative 3, negative 2, negative 1. And let's graph these. So negative 5, negative 3, negative 2, negative 2, and then 10, negative 1, which would be over here, but you don't have to include it. Our vertical asymptote would be at negative 6. And so our graph would look something like that. So your domain is everything to the right of the vertical asymptote. So x is greater than negative 6. The range is all real numbers. And the vertical asymptote is at x equals negative 6. That's your homework for targets 9 through 10. If you have any questions, just let one of your teachers know.